Welcome, everyone. I'd like to welcome you to the Establishing Stability Chamber User Requirements and Selecting a Stability Chamber webinar, sponsored by Stability Hub and Parameter Generation and Control. Our program today is based on the Stability Hub March newsletter article by the same name. And we have with us Jeff Cook of Parameter Generation and Control, who's going to take us through the main points of our topic. And all of you are welcome to comment or ask questions throughout today's session by using the Zoom chat feature. And if you have something that's a little bit more complex, we're open to you unmuting and asking a question directly. Joining Jeff on our panel of subject matter experts are Walter Routh, Stability Hub co-editor and founder of Sagana Consulting, and myself, John O'Neill, editor at stabilityhub.com. In addition, we'd like to think of all of you as an extended panel, contributing your knowledge and experience to our discussion. Jeff, the program is yours.
Thank you, John, and welcome everyone. As John said, what we'll be reviewing today is some of the material from the article on user requirements, how to select your right stability chamber, and 10 things you should be considering during that process. First, I'll just give a little background on myself. I'm the operations manager here at Parameter Generation and Control in Black Mountain, North Carolina. Started off in our service department, and have moved up through the ranks from service to production management into operations management. And I'm heavily involved in our engineering and design team and new product development. So just rolling right into the material, what are the user requirements and why are they important? This is the planning stage of such a big investment on capital equipment cannot be understated. So when choosing a stability chamber, it is essential that you consider a range of factors. The range of factors is astoundingly large and can often branch out to things that you would not usually consider when selecting a chamber. But you want to make sure that you do make those considerations as deep as you can so that you end up with the product that you need for your stability testing. Of course, a big one on that is your tolerances. Defining your tolerances, first off, will define the level of equipment you need in terms of quality, engineering, and with both those things come the expense of the equipment. The scope of the conditions that you are trying to meet. What are your required conditions? Is it just one, or is it a range of conditions? If you do have a range of conditions, does that include rates of ramping between conditions and dwelling at those conditions? Also, your ambient environment around the chamber itself can affect the type of equipment you need to meet your condition inside the chamber. Do you need just simply a bench-mounted chamber or a walk-in stability chamber? Also, renting space from various companies is an option too. So that goes into space. We will cover space more in depth further down. Obviously, utilities is going to be a big factor. What type of power supply do you have at your facilities? Can you modify that power supply easily to be tailored to the chamber you are needing? Another big utility is water. Some chambers require specially treated water. Some chambers can run off facilities water, just metropolitan water. Monitoring systems is a big one, especially as technology is getting better and studies are becoming accelerated, or maybe even longer term studies that are more sensitive to disruptions. You want to monitor that, and we will go into that in a later slide as well. The maintenance is a big factor that you need to consider the quality and accuracy and the performance of the equipment you're buying. The longevity and reliability of the equipment from the manufacturers that you're looking at. What is the cost of the maintenance and how frequent is it going to be needed? Over the course of years, that can add up.
Jeff, I'm going to interrupt and set an example for our audience as we're trying to encourage them to ask questions, although since I'm a host, I can't type as fast as I can possibly ask the questions. So just the scope of where we can get chambers from. I actually checked and saw that you could actually order one on Amazon.com. I've heard of people buying some secondhand reconditioned chambers You can get chambers without the maintenance and service and with the maintenance and service. Do you have any comments on the wisdom of those various options?
From the vendor side of things, John, I'm a little bit blind on that. We certainly do have competitors and sales representatives, but it doesn't surprise me you might be able to purchase some things from Amazon. That might go back to sort of the quality of the equipment that you're looking for based on your tolerances. From the other side of things, Walter may be able to speak to that a little bit.
Well, I mean, a lot of it comes from word of mouth. If you've heard of, I mean, unless you're a brand new stability organization that's never had any chambers, you've probably heard of various good ones. I mean, we went with PGC or Parameter because we heard of them. We'd seen them in action. There were some local groups that could make them and the HVAC guys that could build one from scratch for us, but none of those had the reliability of a formal vendor like you. There's at that time Vindon, I'm not sure what they're called now, and then Banson. So there's several big names out there. I don't know if they're on Amazon.com, but shoot, yeah, if you want to email us separately, we'd be happy to help direct anyone to specific names.
I always wanted to see an Amazon Prime van pull up and unload a chamber room. Okay, Jeff, sorry, I held you up there a little bit, but I wanted to make sure that people knew there was a scope of things out there. And some of them are don't try that at home kind of things unless you can actually handle a reconditioned chamber and make it work.
That's quite, yeah, it is. That's a great question, John, because we do get requests to refurbish chambers or buy back chambers that have been in use for 10 years that are done at that particular customer's. They are done with their stability study. They no longer need this chamber. Will Parameter buy it back and refurbish it and sell it?
Mm-hmm.
A lot of that's based on the customer demand. We don't see a lot of customers requesting refurbished units, but if you were to be looking at something like that, it would probably be in your best interest to look at a manufacturer certified refurbishment. When we refurbish our machinery, we have a manufacturer certification that it is refurbished and it comes with a warranty from Parameter.
It's hard to believe that the cost savings would be worth the cost risk of doing that, to be honest.
Certainly. There can be quite a bit of value inside of a stability chamber relying on a refurbished piece of equipment. So moving on down, just some more user requirements and why they are important. So each party in this planning process will have their own requirements when selecting such a large investment. The quality and accuracy of performance, again, goes back to tolerances. It'll have a big impact on the type of the machine that you need. We put a lot of engineering into our machines just to get another 0.2 degrees in tolerance. A lot of companies do not need the level of tolerance that we provide. And so that can kind of factor into the options you're looking for against the expense and budget that you're working within. Obviously, longevity and reliability of the equipment. If you're purchasing a stability chamber, what is your intended use of the stability chamber? Do you have an accelerated study that's 6 months long? Or you might be looking at a years-long study at an ICH condition of 2350. If you've got a 3-year study, you want to make sure that you've got the reliable equipment to maintain your study for that 3 years with minimal downtime or disruptions. The last thing you want is an alarm going off at 3 a.m. that you're out of spec and the clock starts ticking to get that thing back into spec. The size of the room in relation to the space available is a fairly obvious one. How much real estate do you have at your facility? Is your real estate an open floor that we can fit a square box in? Or maybe you need to work with a vendor that will customize the shape of your stability room. Height limitations are a big one. We make equipment that can sit on the floor next to the room, as you see in the picture in this slide. We also make versions of that same model that will fit on top of the room if you don't have the real estate on the floor. There are pros and cons of both of those. The ones on the floor are obviously easier to clean because you can step right up to them and access them. But then they take up real estate in what might be a narrow hallway that you're trying to roll carts of product up and down. The storage volume needed will factor into the size of the room. How much product are you wanting to put in your chamber? Is it going to be specifically for this study, or do you need to take into consideration future growth, future studies? We get questions on can you actually move a walk-in chamber? The chamber that you see on the slide, you can actually pull the unit off of the chamber and move that box around without dismantling it and rebuilding it. So it's not set there forever. You can actually push them around or take them apart and move them if you do need to. When considering the product that you're going to be keeping inside the chamber, you know, how often and for how long are you going to need to open the door to load and unload your product? If you are going to be needing to open the door often, you might want to consider the layout of the ductwork. If you're going to be rolling carts in and out of the room, you might want to ramp either internally or externally, or even put some wheels on the carts or the shelving themselves. The layout of the shelving, roll right into it. How do you want your shelving laid out? If you have a limited space inside the stability chamber that you're purchasing, you're going to want to optimize the layout of that shelving to fit as much product as you can in there while still ensuring you have uniform air distribution around all the product. We do have quick track high density shelving where the shelving will actually roll together and there's only one aisleway inside the chamber, but that aisleway is variable depending on where you roll those carts. Where you place the shelving will impact where you place your lighting. You need to be sure that you have enough light to see your product on the shelf and also to move around inside the chamber. If your chamber is large enough for you to get lost in, you will need to have some emergency lighting circuits in there as well to be sure that the lights don't go off and you're stuck inside a freezer. So the variables that can go into the planning of this capital expense can very quickly get beyond your initial assumptions. It does take a village to raise the right questions. You would be surprised at how many questions have an impact on selecting the right stability chamber.
Jeff, we had a general question that I put there about are there any specific chamber guidances available? I know that the ICH ones are very vague when it comes to the specifics of chambers. And I believe I've seen a really nice looking document from ISPE about chambers, although I believe you also have to be a member of ISPE or pay specifically for that document. Any other comments on that or from Walter?
The ISPE is a good example, John, of my notes just simply have, there are over the years a lot of standards that the industry has developed for themselves to guide these decisions.
Okay, thanks.
Mm-hmm. So moving down the slides, everyone, we were in your environmental conditions. This is probably one of the first things that you're going to consider when you're looking at buying a stability chamber. What's the condition that you're going to need inside of this chamber? Whether that's temperature, humidity, even light. If you're testing light intensity or light density, those are factors that can be taken into consideration as well. The precise range to which these parameters must be stable. Fluctuations are inevitable, but how tightly can we control those fluctuations? Listed here are some of those tolerance for the ICH guidelines. As you noted, John, a lot of those are vague. And we find that some companies will have their own internal guidelines that are a little bit more stringent than the ICH, just to sort of mitigate the risk of them extending beyond the ICH tolerances. So typically for For ICH standards, you've got 25 degrees Celsius, 60% relative humidity. Those have the tighter tolerances of plus or minus 2 degrees and 5%. As you get towards lower temperature only conditions, such as minus 20 is what a lot of the vaccines for COVID were stored at. Those tolerances get a little more lenient at plus or minus 5 degrees, and then even lower down to a minus 80 degree chamber would involve a cascading refrigeration system that has its own nuanced complexity of engineering and design. So your tolerance are a little bit more lenient there too, with your plus or minus 10 degrees Celsius. So depending on the type of condition you are controlling inside the chamber will factor very greatly into the level of engineering you need to put into the machine you're purchasing. Or we need to put into the machine you're purchasing, excuse me. And then also, do you want to monitor those conditions? How will you know when you're in and out of compliances and when servants or compliance versus when you need to service the chamber? It can also go back to your calibration points and the accuracy of those calibration points. So once you have the condition inside the chamber determined, we're going to be looking at how much room you need inside of that chamber. You can see the picture here in this slide. The shelves are generally loaded. If you're going to be purchasing a piece of capital equipment for a stability room, you're likely going to need to fill that room up with products to make it as economical as possible. So first you need to determine how much product that is. The chamber is going to need sufficient space around the product for proper air circulation and temperature control. You can't simply pack the room floor to ceiling full of boxes and expect that air to be able to circulate around the product and maintain that temperature and humidity. Then you're also going to want to take into consideration future growth needs, the ceiling height, the shelving, and as your shelving nears the ceiling, you will have things that occupy that real estate. The conditioner is going to need to distribute that air around the chamber, and so you will typically have some sort of duct distribution inside the chamber that will occupy some of that valuable space. Lighting inside the chamber, the light hangs down from the ceiling. It might occupy a bit of space that you would have liked to use for your top shelf. If
We
you
have
have
a
an
question from one of our audience that going back a little bit to the guidance question, is there any guidance on chamber selection for light sensitivity studies? I don't know if that's your area of expertise at Parameter. I am aware of some things, but I'll let you comment first.
Certainly, John. So we do build light sensitivity chambers. Depending on the type of light, the intensity and density of light you're needing, we find that the light chambers need a significant amount of airflow to control that heat and still maintain our temperature and humidity. So we typically build small benchtop cassettes as light chambers with an internal volume of probably just about 6 cubic feet.
Okay, and then I think what we're looking for somebody who is brand new to the idea of the light sensitivity, you're referring to the photosensitivity or photostability aspect of a stability study. And if you look in ICH guidance Q1B, you can find some of the specifications for the light that you need to use. As far as selection goes, I think that's kind of up to you. Each company has some features that they go into that they're stronger in some areas more than others. A lot has to do with your selection of light meters, spectrophotometers that let you know where the wavelengths are and what the strength is. In my early days, I was pretty naive. I was just going by foot candles. And then I ran into somebody at the FDA who asked me a lot of questions and caused a lot of research, and then realized about the impact of the wavelength and what kind of intensity you had there. So there's a lot of information. If you look in the publication section of Stability Hub, you can find some articles on that. You can go on the general internet and do some searching for that, and it'll tell you a little bit more about the photostability chambers that are out there. And then there's typically two options. Option one is a very intense xenon light. Option 2 is a combination of fluorescent and incandescent that puts the wavelengths together. And then in Europe, they tend to go with option 1 a lot. In the US, option 2 has enjoyed a greater popularity for some reason, but you could use either one. I would suggest reading through the guidance to catch up on that.
Very good input, John. Thank you. Are there any more questions out there?
I don't see printed ones.
All righty, we'll just roll right along then. So going back to the storage, obviously your available real estate, the size of the room, the height limitations that you have on that room, the equipment to control the room can occupy precious space. A lot of temperature only chambers will have an internal evaporator hanging inside the room from the ceiling. That's valuable space. We provide internal evaporators. We also have machines that will be temperature only that can sit on top of the room and pull the air out of the room and reintroduce it. And that allows you to retain that valuable space inside the room for your stability studies. The equipment, the shelving, and the product that you're keeping inside the room can all affect the airflow and uniformity. So where you place your shelving, where you place your product, even where you place your control sensor. If your control sensor's hidden in the back corner behind a box, it might skew your uniformity. So these are all things that you really want to take into consideration during the planning phase before you get to the qualification phase and find out that your sensor's in a bad location. If you have sprinkler heads inside the room, a lot of places require sprinkler heads, fire suppression. Those sprinkler heads are going to be occupying precious space on the top shelf. I believe Walter mentioned at one point that he wasn't even allowed to use his top shelf because the water from the sprinklers would not extinguish a fire if it happened to occur there. So all things that you might not think about right off the bat. And it's very important to get all the interested parties just throwing all the questions out there you can possibly think of, because you'd be surprised at how much impact they can have. If you're going to be rolling a product in and out of the room on a cart, you might want to consider a ramp for the room. When we're speaking of ramps, do you want the ramp inside the room or outside of the room? If you put the ramp inside the room, if it's a crowded room like you see on the slide here, you might have some ADA considerations to take into account. If you put the ramp outside the room, again, if you have a narrow hallway, it might not be an option for you. So it can be tricky. The lighting inside the room, we actually place the lighting based on the shelving layout. So the size of the room, the type of study you're doing, and the type of product you have will all have an impact on how we lay out the shelving. Once the shelving layout has been determined, we can then decide where to place the lights so that you can see your product and also navigate safely inside the room. So here in this slide, you can actually see one of our large units conditioning a chamber. So one of the first things that we look at when we are engineering and looking at the space requirements of your room is just very simple, but can sometimes have a pretty big impact. Where do you want the door? Do you want the door to swing inwards or outwards? If you're in a -80 freezer and it's pretty warm and humid outside your chamber, it can get pretty tough to open that door because the outside pressure is pushing that door closed. So you might want to consider having that door in a conditioned environment to make it easier to push open and closed. Do you need an electric door for forklift access to drive in and out? Do you need your door to have an alarm in case someone leaves the door open, or a high pressure, hot and humid condition inside the room makes it hard to close that door? Do you need your door to be heated? Same with the windows. If you have windows and they are not heated, then you might just have a foggy window that's a source of water inside your room, skewing your uniformity. If you have a very large window, it might not matter how much heat you put on the sides of the window. The center of the pane is going to condense and it's going to run water down inside your room. Are the conditions inside your chamber dynamic? Are they ramping and dwelling at different conditions? And if so, you would want your door and window heater to do the same. Some chambers will just have straight power to the heater, running that heater on all the time, and you might lose a bit of uniformity near your door or window because of the amount of heat they're putting off. We will actually tune our door and window heaters to operate at just 1 degree above the dew point inside the room to only keep the door and window as hot as needed to prevent the condensation from forming, but also retain your uniformity inside your entire internal space. The internal lighting for visibility, where do you want the lights? What type of light switch do you want? Do you want it to be just a simple light switch or a timer or even a motion sensor? If you have a motion sensor, itself will have a timer. You want to make sure that it's timed well enough that you don't get blacked out while you're inside the room and not be able to find the door. If you do have a room of that size, do you need a safety lighting circuit with an emergency exit light? Sprinkler systems, sprinkler heads, as I said, they occupy space inside the room. Typical sprinkler heads will have water right there at the sprinkler head to engage when the valve opens. Most of the time, that water is fairly cold. If you have a hot and humid chamber, that sprinkler head is going to condense water and drip water inside your room. And over time, you'll just have a puddle inside your room. So you can actually get dry sprinkler heads that will pull the valve about 6 inches back from the tip of the sprinkler, and you can have a dry sprinkler head inside your room. Event timers for various operations. Again, ramp and dwell times. Do you need ramp and dwell times? Does your vendor provide the programmability to automate those ramp and dwell times? Door open alarms. How long do you want that timer to be set for? Well, an alarm starts going off on a stability chamber, it can concern people very much. So you really do not want errant alarms. If you get an alarm, it will typically go into an alarm log that will be looked at. So you want to minimize the number of alarms you get, and you want those timers to be set as such. Another one on event timers is going back to your lights, your light timers, and your light motion sensor timers. The internal escape mechanisms, most walk-in stability chambers come with the automatic push knobs that you cannot actually get locked inside your chamber. But if you do not have a door heater that is working sufficiently, if you open the door to a minus 80-degree chamber, that door might have some condensation on it, and the door jamb could freeze the door shut. It's a scary thing to be inside of a freezer with the door frozen shut. So things to consider. You need to make sure that door heater is working and that you have some mechanisms to get out. The ramps we went over, that's a big one. Just whether you have the space, the real estate to put the ramp outside the room. If you can put the ramp inside the room, you're going to occupy some of that valuable space that you paid for. You can recess the floor of the chamber into the floor of the facility. That will require its own engineering to provide a thermal barrier. And then maintenance considerations, the external mechanical components. Again, this unit that you see on the slide is a floor mounted unit. We do make a model of this unit that can sit on top of the chamber. What does your real estate look like as far as, do you want the unit on the floor or on top of the chamber? Sometimes you put the unit on top of the chamber, you build an entire office space around that chamber with a drop ceiling. Utilities run all over the top of the chamber, and you can see that unit being neglected because people forget about it. It's sort of out of sight, out of mind, sitting above a drop ceiling. And unless you are very intentional about your preventative maintenance, you can have a unit go down and find that the repairs needed are much beyond what would have been needed if it had been properly maintained.
Sounds good. We have a question and also a point of order. We are at about halfway point time-wise. The question is there a best practice external temperature and relative humidity level to aid in optimal chamber function, or maybe a rule of thumb around that? is there a standard cooling capacity that HVAC units in the stability area should have to do that? And then there was a follow-up with a shift in external temperature and humidity, such as an incoming rainstorm. You see a shift in humidity within a humidity controlled chamber. So does the outside room influence the inside? And what should be the best practice for maintaining the conditions in the outside room?
A great question. You do need to maintain the temperature around the conditioner itself. That is most frequently in the case of an air-cooled unit. The units will have a refrigeration system. It's simply removing heat from your chamber and exhausting it into your ambient environment. If your ambient environment is too warm for the unit to sufficiently exhaust heat, you will lose the ability to cool that chamber. Parameter units are spec'd to operate in an ambient environment anywhere from 65 degrees Fahrenheit to 95 degrees Fahrenheit. That's a fairly wide range that covers most comfortable conditions. But again, even if you are within that range, if you swing from 65 degrees to 95 degrees in a 30-minute time period, while muted, you will see a small swing of the performance inside the room. The humidity is less concerning when it comes to ambient because the rooms are generally vapor sealed. So the room on the side that you see has silicone in the seams, and the entire system is vapor sealed in its own environment. So it's really just the temperature swings in your ambient environment. And as you put more air-cooled units in the same facility, those air-cooled units will all be exhausting heat, and you can overload your facility's HVAC very quickly if you put 5 air-cooled units next to each other in a stability room. That's when we start looking at options to water cool units, where the refrigeration system is cooled by water that's flowing through the facility. So that comes with its own design considerations on the front end when planning your project. I realize we're at halfway, but I think it'd be kind of fun to take a little poll to get everyone engaged. How many of you would prefer the conditioner on top of the room versus it being on the floor besides the room?
Sounds good. We'll make Walter our teller for this. And then if you can use your chat feature just to raise your hand. And I think the first part of the poll will be how many people can answer this question as our baseline. Walter, are you in position to be able to count?
Yeah, so people just use the react button at the bottom to raise your hand, bottom of your Zoom screen.
Give everybody a second to do that. If you can answer the question, put your hand up. Yeah, what's our baseline?
There's 5 people. That's 6, I guess, ultimately.
Okay, 6 can answer. How many people would, okay, you need to take all your hands down again. Thank you. And then how many people would say, and Tamar, you need to take your hand, there you go. How many people would say they'd like it on the top out of those 6? I can't spot everybody's name on my screen.
We have 4.
4 out of 6. So we'll assume the other 2 want it next to it. Okay, so and that seems to be fairly typical. A lot of times people will opt to have the available real estate versus the convenience. Although if I was an HVAC technician, I'd be sending you gifts if you voted for the alongside.
Yeah.
I think I read an article about the impacts of that at some point in time. Okay, thank you.
Yeah, of course, John. I'm on your team, but I guess I'm the HVAC guy. So
there you go.
Okay,
so let's roll along then.
Yeah, we'll keep rolling along. I appreciate the time warning. I'll roll through some of this stuff a little quicker. So obviously, utility requirements. The first one is going to be power. What is your preferred power? Can your stability chamber meet your required conditions with the power that you have at your facility? If not, we can look at considering transformers because the lesser power that you have, the less power your machine's going to have, and you'll have reduced capability of that machine. Is your power stable? Do you have power fluctuations? If so, we might want to consider a UPS to maintain the electronics and sensitive controls inside the machine to protect them from rolling brownouts and things like that. Water is just going to be the second one. What is your preferred supply water quality? Do you simply want to use facilities water from your city, or do you have a robust water treatment system? Do you have no water at all, and we need to consider putting a large carboy on top of your unit to gravity feed it that gets filled periodically? Especially this day and age, deionized and highly pure water are something that a lot of vendors require for their humidification. Parameter actually prides ourselves on not needing any sort of water filtration at all. You have coolant water for water-cooled systems. Is your water well water that has sediment in it that can deteriorate the internal components of your machine? Do you have gas in your environment? Do you need a gas fire suppression system or some sort of pressurized air for a standard manufacturing environment? A large utility requirement that is often overlooked is the drain. Do you have a drain? Is the drain nearby? Do you have enough drop in elevation to get to your drain to ensure that your drain line doesn't become clogged? It's very frequent that a drain line can become clogged and cause a unit to flood. We are dealing with humidification and dehumidification. So as you're dehumidifying, you need that water to go somewhere. And if it's going to a clogged drain, it will find its way out somehow. So the drain is a big one.
Might add that when you do drain it, know where your drainage is going and what the local requirements are. Your company may be charged with knowing exactly what's in the water or certifying that there is nothing in the water as it enters the local municipal system. So just check on that location by location.
Very good point, John. Ventilation. This goes back to the question about the ambient temperature. The air-cooled units do need to run in an environment between 65F and 95F. The duct layout inside the chamber is often specific to the application. If you're going to be having frequent door openings, we will build a duct distribution system to capture the air right next to the door to prevent it from impacting the uniformity inside the chamber. The chamber location itself, the chamber manufacturers, the room panel manufacturers, they will actually recommend often that 2 inches of space be left around the 4 walls of the chamber for ventilation to prevent mold growth or condensation or anything like that. If you have chambers next to each other, that 2-inch gap is often not very aesthetically pleasing. So it is very frequent that we'll want to just push the chambers together, and is often not advisable. So to gain that aesthetic pleasure, we'll just put a piece of trim there to make it look like the chambers are sticking together. But even if your ambient is within the acceptable range, if it is changing rapidly within that range, you will see those muted swings in the conditioner or inside your chamber. Does your electrical or mechanical compartment need to be ventilated? If you have a -20 or a -80 degree room, that unit is removing a lot of heat, and your compressor and motors will get very hot. Sometimes the compressor itself can bring the ambient temperature around your refrigeration system above that 95, and we will ventilate the mechanical area ourselves with a fan. The availability of your parts and components is a very big one, especially with how technology is changing and how quickly refrigerants are being phased out and upgraded based on climate change and technologies. You want to make sure that your vendor is stocking spares, is supplying you the service support when you need. Parameter actually just posted a blog article on this very topic recently on our website, humiditycontrol.com. Not all manufacturers are parts warehouses? Does your vendor stock spare parts for you? Can you include in your URS spare part availability for 5, 7, 8 years? And will your vendor provide that for you? Does your vendor use parts that come from reputable suppliers and then will offer spares well into the future? Will they support you when a part goes obsolete with a suggested replacement and the fittings needed to make that replacement work in your unit? Does your vendor support upgrades to new generations of parts? As refrigerants change, the compressors change. As electronics and technology becomes smaller and more powerful, a lot of old controllers you actually just cannot get off the shelf. In order to replace the controls in your unit, you might have to rewire the entire unit, and will your vendor support that? So Parameter will provide our customers with a recommended spare parts list that is prioritized based on the expected lifespan of the part and our historical experience with those frequency of failures. We do have a list of parts that we encourage people to have on hand. On down to the service and preventative maintenance. How easy is it to maintain your machine and perform regular maintenance on it? Can it be taught? Can it be learned and easily done by non-experts? Will your vendor provide those teachings, those lessons? And what sort of options does your vendor provide to teach that? Will they do on-site training at your facility? Parameter offers a twice-a-year seminar here at our facility where any of our customers can come get hands-on experience with us. And we often offer extended warranty or discounts on spare parts and future orders based on those lessons. Does your vendor have service contacts? When you call them, do you get a person on the phone or a machine runaround? Even when they do answer the phone, do they have technicians available? Or do they have a network of local technicians that might get you quicker, cheaper service? Based on the type of machine that you're looking at and the condition you're running, how frequently does that maintenance need to be done? You'll need to work with your vendor and your specific application and location to determine a reasonable frequency to do that preventative maintenance. And optimally, if the maintenance is preventative, it can be done by the user, and you don't need a refrigeration license to just do regular preventative maintenance on your machinery. And then beyond the regular maintenance, it's not an ideal situation to be in, but when you do need emergency service, will your vendor be there for you? Do they have providers that are local? Do they answer the phone in the middle of the night when you contact them? Do they provide 24/7 phone support and 24-hour response times for on-site service? All things that can have a great impact on a long-term study that should be taken into consideration when choosing the vendor you're going to go to.
If I can, on the topic of parts and maintenance, one other thing to consider is just the stability of your vendor, not the financial, are they going to be around in 5-10 years to still replace parts, the same parts? Ideally you can replace like for like and not have to requalify after every maintenance event or and such. So, and also, if they're well established, they have the connections with maintenance organizations around the country, hopefully, or things like that to consider as well.
Certainly, Walter, an excellent question, because establishing those service networks is very difficult. Similar to finding a car repair shop. You almost never know. You can do all the homework and legwork you want, but it's a very difficult thing to determine whether your service provider is qualified. Does your vendor have a network of certified or preferred vendors that they can provide you based on your geographic location? So connectivity, especially as technology is advancing, and their AI is entering the world of connectivity in terms of stability chambers. But you definitely want your stability chamber to have a reliable alarm system to alert you of malfunctions. Even if it's not a malfunction, it could be a simple mistake that someone left the door open. You want that alarm to notify you as soon as possible so that you don't run into an out of spec situation. So you got to consider the level of connectivity that you want. Does your vendor provide connectivity at all? And you as the user, what level of connectivity do you want? Do you want your unit to be networked or put on a Wi-Fi network that might open it up to risk somehow? We have found that oftentimes folks don't want their unit to have web access, to be able to go to a URL and actually pull up the controller from your phone and change set points and things like that. So beyond that, beyond what level of connectivity you, the user, want, what level of connectivity might your IT department allow you to have? What type of communication protocol do you have at your facility, and is your preferred communication protocol from this unit? Is it a BMS? Is it a SCADA? Is it BACnet protocol? We provide just Modbus TCP that can be tied via IP addresses to various protocols. We do have software that can email, that can send text. The more connectivity capability that you build into the machine, the more you might be opening it up to risk. A big level of connectivity that we are working on and very proud to be on the cusp of is component health monitoring. Does your machine warn you when the heater is drawing too many amps and is imminently about to fail? If you go out of spec, can your machine simply tell you it's because the pump has failed? Things such as that. Does your machine flag you and tell you it's time to perform preventative maintenance based on hours of runtime? So those are the types of component health monitoring that we're looking at.
Yep.
You can even go ahead, John.
We have a question, any recommendation for an add-on alarm system? And I know there's a number of them out there. I'm not sure Parameter is connected directly with one of those that you use as a standard, or perhaps there's a pool of ones that people could look at. We've got a lot of feedback on a number of alarm systems that we wouldn't have time to go into right here, but people are welcome to call and ask anyone at Parameter or anybody at Stability Hub to talk a little bit about those systems. But having said that, I'll flop the question over to you.
Good question. We find that nowadays a lot of larger companies will have their own BMS systems, that their IT professionals will set those alarms up in their own software. I learned about a very exciting system that I'm interested in pursuing during one of our recent webinars with Stability Hub was Novatech. Novatech I thought was very exciting, and I'd like to look further into. There are, especially with the development of AI and the software that can digest all the data that the unit can provide to that system, there are several emerging companies with such software.
Yeah, I would just add on that that's a very important consideration. So thank you, Jennifer, for asking that question.
So we
have
got
about 10 minutes.
Thanks, John. Yep, exactly. So your system does go into alarm. You do need a part replacement. That part has a lead time, or you don't happen to have it in your stock room, or it has become obsolete. What do you do then? If the level of study or level of stability chamber that you are needing is of such value that the failure is just not an option, a backup system might be a consideration when choosing your stability chamber and stability chamber vendor. If you do decide that you were considering a backup chamber, how far do you go with that? Is it simply a backup power source? Is it simply a UPS to keep the sensor and the control collecting data during a power failure? Do you want a fully built spare unit If you do have a fully built spare unit, is it simply a spare unit that is easily wheeled over and reducted and plugged in? Or is it already ducked in with manual valves and dampers that are shifted when needed? Are those valves and dampers automated through your BMS? If they are automated through your BMS, do you determine a time frequency of change? If it's a freezer, you might not have a time frequency. You might base it on the need to defrost that coil. If you do have those valves and dampers, whether they are manual or automated, do you have the knowledge that you need to switch those systems over when they need to? Does your vendor provide comprehensive operations manuals so that you can read that and switch your unit over in the middle of the night during an alarm condition? It also depends on the condition that you're running inside the chamber and the setup of the whole system. Stability chambers can often stay in spec for hours and hours after an outage. Again, that'll depend on your ambient temperature and the condition inside the chamber. And all of that will factor into the type and level of redundancy that you are going to go into during your planning phases. My last topic for everyone is disaster protection. We recently had a pretty significant disaster here in Western North Carolina, and we've had some of our customers dealing with it. So having a plan in place when you purchase your chamber, it's all about risk mitigation. So floods, even regardless of a flood from Hurricane Helene, the chamber can flood itself via a clogged drain. If your chamber's on the roof, as seems to be 60% of the attendees' preference, you will have water running to that chamber, and it's going to be on the roof of your stability chamber. If that water pipe springs a leak, you can flood your facility. Has your chamber been fully vapor sealed to prevent that flood from affecting the product inside the chamber? Is your unit serviced often enough to prevent that clogged drain? And then additionally, there can be some measures you can take to sort of notify yourself of an alarm when a flood does happen. We can put the units in a large basin with a spill sensor that will alarm your BMS, or just audible alarm in case it does detect a flood. Fires. We've had units experience fires. Fires happen. Are there sprinkler systems allowed, or do you have the appropriate sprinkler systems installed? There are pressurized fire retardant systems. Is your process inside this stability chamber particularly at risk of a fire with a volatile chemical or a polymer? In those instances, you can buy a stability chamber that is FM rated. Earthquakes are another one. We ship units all over the world, particularly in California. We take special consideration to make sure that our units have seismic tie downs. We tie the entire chamber to the facility floor, and we take special steps to anchor the units to those rooms. And again, if the roof is blown off during the tornado, I do not know if the stability chamber would blow away with it. But just things to consider. Disaster planning to mitigate the risks. It's still what could go wrong. And again, when you're considering all the variables that can go into choosing the right stability chamber, it really is sort of brainstorming and thinking of all the situations that could impact the decision.
So we have a question here from Chris. Do you have any recommendations for periodic cleaning of chambers, especially accelerated chambers? And he was asking, should we use maybe something like dilute bleach or something just because of black mold on the shelves, etc.? Any recommendations there?
Yes. So the inside of the chamber versus the inside of the air handler can be a little bit different. The use of bleach is something that we sometimes recommend, but is sometimes not allowed depending on what you are storing in your stability chamber and the impact that might have on the mold growth is definitely something that we have dealt with. If it is an accelerated study, if your stability chamber's air handler has the capability to run a range, if your accelerated study lasts 6 months, at the end of the study, you can actually tune your machine to dry the entire room out and kill all of that mold. You can use diluted bleach. We will sometimes even put bleach in our air handler, disable the fan that's circulating air into the chamber, and simply run the pump and circulate that bleach throughout our entire system just to get that thorough cleaning. Accelerated chambers, they're incredibly harsh environments. They come with their own set of maintenance needs. And a lot of that is very dependent on what you as the user are storing inside the chamber and are allowed to clean your chamber with. If anyone is interested, I do have a list of recommended cleaning agents depending on what sort of growth or algae or anything, sort of sediment. Um, Depending on your application, you can be dealing with different sorts of dirtiness that needs to be cleaned.
That would be great to put on your website to share with folks.
Noted. We can definitely do that.
It sounds like if you've got the luxury of being able to empty the chamber, then you could pretty much do whatever you want as long as you're not killing the walls.
Yep. You will find that a lot of stability chambers, the inside of those walls are coated galvanized. And so if you do scour that galvanized by scrubbing it pretty hard, you could potentially show some rust during future accelerated studies.
Is there any sort of inline cleaning, with clean the air before it goes in the room?
So we do use various filters, depending on what your needs are. We can look at HEPA filters. We can look at off-the-shelf residential filters. Sometimes a residential filter, if it has a cardboard frame and a cotton-based filter, it can actually be food for mold. We do put UV bulbs in our plumbing to help with algae growth. We do have various filters depending on if it's hard water that we're filtering or if it's sediment that we're filtering or if it's simply particulate from the air, maybe in like a paper pulp manufacturing process that you're ending up with a lot of that paper pulp in your machine. Some of our machines actually have air filters in the circulation systems.
We're just about down to our last minute here, so I'll ask anybody else with other questions to either submit it directly to Parameter Generation Control at humiditycontrol.com or go to the forum of stabilityhub.com. We'll be glad to post those questions, see what people have to say, and we'll take a crack at answering it ourselves as well. So now that we're just about out of time, I want to thank our Parameter Generation Control guest presenter, Jeff Cook, co-host Walter Routh, and all those who attended today. We hope that you can take away information that will improve or preserve your chamber compliance or bring greater efficiency to your operations. You can check out our sponsors' products and services at humiditycontrol.com. A recording of today's program will be available soon at the Stability Hub website events section. We ask that you please join us again for subsequent programs in the Stability Hub webinar series. The April webinar is on stability statistics digitalization. May is Stability Information Month with an office hours webinar to address your stability questions. And we'll pick up the chamber series again in June with validation, calibration, and ongoing requalification measures. The schedule can be found in the events section on stabilityhub.com and in our monthly newsletter as well. That wraps it up for us. And we wish you all a good day. Thank you very much for attending.
Thank you all.